In this video, we're going to be looking at angles and some of the terminology that's used when discussing them. We'll go on to look at types of angles and how the properties of those angles, along with parallel lines, can be used to solve what the size of an angle is. We'll also show how to give reasons in an example exam question at the end. Here we can see some of the words that are used when discussing angles. Firstly, we've got points. All angles start off as being the degrees around a point, which we'll discuss is always 360, unless it's restricted by some lines emanating from it. The angle will be measured as the amount of turn to get from one line to the other. We can measure them using a protractor or calculate them using our knowledge of angles. Lines can either cross over at angles or they can be described as parallel, which means they never meet, and we symbolize these using chevrons on both of these lines to match. This understanding can be used to solve what an angle is. If a line crosses it at a right angle, or 90 degrees, it's said to be perpendicular. Finally, we have a protractor, which can be used to measure an angle and is a piece of equipment you may need for an exam. The parts to point out on a protractor are the central bullseye, which is the part which is placed on the point of the angle you're trying to measure, and the two sets of numbers that run around the outside. If it runs to the left on this protractor, you'd measure using the outside set of numbers, and if it runs from the right, you'd use the inside set. We're going to talk about the names of different types of angles. We start with the central point here, and from the left-hand side we have 0 degrees. Now, if we create an angle anywhere up to, but not including, a right angle, it would be called an acute angle. So that's anywhere from 0 up to 90 degrees. 90 degrees is called a right angle. Anything from a right angle, or 90 degrees, so greater than that, and up to but not including 180, would be called an obtuse angle. 180 degrees is called a straight line, and we use this quite often when solving equations. From 180, right the way round, almost back to 0 again, up to but not including 360 degrees, so going from 180 up to 360, will be called a reflex angle. So we get to 360 degrees, which is called a full turn. This is sometimes referred to as angles around a point, which always equals 360 degrees. Next, we'll use some of these reasons to look at how we'd answer questions in an exam. Here we have 3 lines and several points. In many questions on angles, you're asked to give reasons for why you're stating certain angles can be observed. These don't need to be long essays, but clearly state your reasons for using the numbers that are not included in the actual question. We'll use this to show how to state these properties of angles and how to go about solving some problems. So first of all, we'll start off by using one that's very common, which is this: angles in a straight line. Angles in a straight line will always equal 180. Next, we've got these 2 straight lines that cross at this point. Either side of here, we can say that these values are both x because they're equal. They're what's called vertically opposite angles, and they're formed by 2 straight lines crossing at a point. And here we've got an example where we can use that first reason to solve a question. If we drew an angle here, it would be y, and we could say that x plus y would equal 180, and our reason for stating that 180 is that angles on a straight line equal 180. If we're told that 2 lines are perpendicular, we can then assume that it's a right angle. So we know that the angle here inside this triangle is going to be 90 degrees. One of the things that we'll talk about a lot in the next video, which is going to be on polygons, is the angles inside a triangle. The angles inside a triangle always equal, again, 180. If we know that the angles inside a triangle equal 180, we can use that as the reason for what this missing angle is in our triangle. It's going to be 180 minus 90 plus whatever that other angle is, would give us the missing angle. Here we can see 3 sets of parallel lines. In each case, there's a straight line that goes through both of the parallel lines. We can be certain that they are parallel as they have that chevron symbol on each one to state that they are parallel to each other. As these are parallel lines, we can also state that this line crosses both the parallel lines at the same angles. And this is the basis for our parallel line rules, which are shortcuts to state certain assumptions about these angles. So firstly, this one on the left-hand side, we can state that this angle is equal to this angle. Because if we shifted the one at the bottom up, it would be vertically opposite. These are called alternate angles, and we can state that alternate angles are equal. On the one in the middle, we can state that this angle equals this one. This, quite simply, shows that a line that goes through the parallel lines will do so at the same angle on both lines. And we can state that this is a corresponding angle, and therefore these are equal. The next one is two angles that are inside the parallel lines. Now, if we were to take the bottom angle and move it up to the top, we could see that they would create a straight line. These are called co-interior angles, and we can state that co-interior angles add up to 180. This next slide shows us an exam question which asks us to calculate the value of the angle x. Now let's review all the information that they're giving us in this question. First, there's a set of parallel lines, as shown by these symbols on each of the lines which look like arrows. Secondly, there's two further lines drawn along that form a triangle between these two lines. This happens to be an isosceles triangle. We'll show you more about these types of triangles in the next video on polygons, but one of the properties is that two sides and two angles are always the same. This is designated by these two short lines that cross the triangle sides. These also means the angles at the base of this triangle are equal. I always think of these short lines as arrows pointing at the base angles which are equal, like this. Also, we're given that this angle here is 142. And we're going to calculate x using the information that we've discussed in this video. So the first thing we can do is we know that angles on a straight line equal 180. So we can find this first angle inside the triangle by doing 180, take away 142. And the reason for us using that 180 is the angles on a straight line. Now we also know that the angles in a triangle equal 180. So if we subtract 38 from 180, we get 142. And then because the base angles on an isosceles triangle are equal, you can divide that 142 by 2 to get 71. Now we know that the angle at the bottom of this triangle is 71. The angle to the right-hand side of it, we can say is an alternate angle to the 38 above. So lastly, to find x, we know angles on a straight line equal 180. So we've got 180, take away 38 plus 71 will leave us with 71. And we can state that x equals 71 degrees. In this video, we spoke about the terminology that we use when talking about angles. We talked about the different names for the types of angles that are used and their properties. We've also looked at parallel line rules and an example exam question where they were used to solve the problem. In the next video, we'll be looking at polygons, which are two-dimensional shapes which use straight lines as sides. I'll see you then.